What we're talking about today is lesson 88, multiplying and dividing rational expressions. It says multiplying and dividing rational expressions is the same as multiplying and dividing fractions. Okay, the great part about this lesson is you already know all the rules that you need to know about it because you already know how to multiply and divide fractions. Remember, when we multiply fractions, we multiply straight across, numerator times numerator, denominator times denominator. When we divide fractions, we keep the first one the same, change division to multiplication, and then take the reciprocal of the second fraction, and then just multiply straight across. You also remember your exponent rules. When I multiply by the same base, I must add the exponents. When I divide by the same base, I subtract the exponents. So, let's go ahead and get started here. So, some examples that they give us are 2/3 times 5/7. They show that we multiplied straight across. 2 times 5 is 10. 3 times 7 is 21. Okay, then they give you the concrete example, which is, or not concrete, that's not the right word, but you know what I'm saying, the variable example is what we'll call it because I cannot think of the right word for the life of me. A times C over B times D. When we're dividing, like I said, the first one stays the same. Change multiplication or division to multiplication, take the reciprocal and then multiply across. Same thing with this. So it says find the product of each. When I am multiplying fractions, I multiply straight across. So I'm going to take 2 times 5 gives me 10. X to the second times x to the fifth. Remember, when we multiply by the same base, we add the exponents. And then I have y, which is to the first, plus y to the third, all over 12 times 4, which is 48, x to the first times x to the fourth, which means I'm going to add those, and y to the fifth plus y to the fourth, well, not plus y to the fourth, y to the fifth plus the fourth. Then I have 10, x to the, and 2 plus 5 is 7, y to the fourth, over 48, x to the fifth, y to the ninth. Now I'm not completely done here, okay, because I still have some simplifying that I can do. First of all, I have 10 over 48, which will reduce. I can reduce it by 2 on top and bottom. So 2 goes into 10 5 times, 2 goes into 48 24 times. Then I have x to the seventh over x to the fifth. I always want to move this smaller exponent, so I'm going to take this one. I'm going to move it up here, so I'm going to subtract that 5. I have y to the fourth and y to the ninth. I want to move the y to the fourth because it's the smaller exponent, and I'm going to subtract that 4. So when I completely simplify this, I'm left with 5, the x to the seventh minus the fifth, so x to the second, over 24, and on the bottom I had y to the ninth minus the fourth, which is y to the fifth. That is my final answer. Okay, we're going to do the same thing with problem B. What I would like for you to do is try this on your own paper. Please pause at this time so that they have a chance to get it done. Okay, so what we're going to do is we're going to multiply straight across just like we did above. So I have 8 times 2 is 16. X to the third times x to the second, which is x to the third plus the second, over 5 times 9 is 45, y to the fifth plus the third equals, okay, now is there anything that I can reduce by here? And the answer to that is no. So this just stays as 16 over 45. This is x to the fifth, and on the bottom is y to the eighth. That's my final answer. On example 2, it says multiply and simplify your answer. On these, I have 16 over the quantity of 4x minus 32 times this quantity. What I'm going to do is I'm going to simplify this part to the best of my ability first. I see on the bottom that I can factor that. So I have 16 on top. I can factor a 4 out of both of those, which leaves me with x minus 8. Okay, and then it's still times x to the second minus 5x minus 24. The 4 and the 16 reduced by 4, so this goes to a 1, this goes to a 4. So I have 4 over x minus 8 times the quantity of x squared minus 5x minus 24. And all I have to do now is distribute this to everything on the inside. Now this one is a fraction, this one is not. Okay, these are not. I can change them to a fraction by putting them over 1. Okay, so when I do that, I'm going to have 4 times x squared on top over this times 1, which is just going to be that denominator, minus 4 times 5x over my denominator of, well, I don't know why I just wrote 4. Let's just scratch it out. X minus 8 minus 4 times 24 over x, that was supposed to be over 1 there, x minus 8. Okay? So now that I'm here, I can go ahead and simplify what I have on top. So this is going to give me 4x squared minus 20x minus 4 times 24 will give me a 6 and 96. And all of that is over x minus 8. Okay, because if I have the same denominator, I can write it as all one thing. Now that I'm here, I would guess that I can probably factor this whenever I have this quantity in the denominator. So I see immediately that each of these is divisible by 4. So I'm going to factor out a 4 to make it a little bit easier on myself. So I have x squared. If I take 4 out of that 20, I'll end up with 5x minus, and this is going to give me that 24. I just went right back to where I was essentially. I have made this a longer process than what I maybe needed to. So now I can go ahead and factor this. I need something that multiplies to get me this, but adds to get me this. Okay, so things that multiply to get me 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, of those I can get a 5 with that 3 and 8. So I have 4. I'm going to open up 2 sets of parentheses. My x squared is going to become x times x. Because I'm multiplying to get a negative here, I know I have to have a positive and a negative. Okay, and to get a negative 5, I want the larger number to be the negative, so 8 is going to be negative, and 5 will be positive, all over x minus 8, which means that these two quantities cancel, because they're exactly the same. And that leaves me with 4 times x plus 5, which I could then distribute to get 4x plus 20. Final answer. Let me actually look and see how they, oh, this is not, yeah, they went ahead and distributed. Okay, it says multiply, simplify your answer. Whenever you're doing a problem like this, you need to make sure that you remember that you're taking this whole quantity times this whole quantity, because you are going to have to look at it as on top we have 3m squared n plus 2mn times 11 over on the bottom I have 2m times 24mn plus 16n. Okay, because I'm going to have to distribute on the top and on the bottom. Okay, so when I do this, I get 11 times that 3m squared n, and give me 33m squared n, plus when I distribute this one I get 22mn over on the bottom when I distribute 2m times 24mn, I'm going to get 48. M times m is m squared n, plus 2 times 16 gives me 32, and then I have mn. Okay, I can simplify this further because I can factor out of both of these to simplify. So on top I can obviously factor out that, let me look back at what my original was to make this more complicated too. On top I can take out 11mn because I have m squared and m, so I can take an m out of both and n out of both. So I'm left with 3m plus 2, okay, that's it there. On the bottom I can take out 8, 16 from both. So if I factor out 16 and then I have m squared and m, which means I can take out an m. I have n in both, so I can take out an n. 48 divided by 16 is 3. M squared, m came out, leaves me with m. The n is gone, plus 32 divided by 16 is 2. The m and the n came out, which means that these cancel, and the m and the n cancel, which means my final answer is 16 over 11. So awesome when we can take something that looks really ugly like this and turn it into a nice simple fraction. I know that you guys like that too. Okay, on example 4, we're talking about finding the quotients. Remember, we're going to follow the exact same procedure, except for we have to deal with the fact that this is a division sign first. So, I have 3s squared t to the 5th over 5s to the 4th t to the 6th. Division changes to multiplication, and then I flip this one, so I have 10s t to the 3rd on top now, over 9s to the 3rd t to the 5th. All I have to do is multiply straight across. So 3 times 10 is 30. S squared times s, that's going to be 2 plus 1 is 3. T to the 5th times t to the 3rd is 5 plus 3 is 8. Over 5 times 9 is 45. S to the 4th times s to the 3rd gives me s to the 4 plus 3 is 7. And t to the 6th times t to the 5th is t to the 11th. Okay, now I can do my simplifying. I have 30 over 45, which can both reduce by 15. So 15 goes into 30 2 times and into 45 3 times. I have s to the 3rd and s to the 7th. I want to take that 3 and bring it down, so I'm going to subtract it. T to the 8th and t to the 11th, I want to move the smaller one again, so I'm going to bring it down and subtract it. So what I'm left with on top is just 2, because these two things both moved. So I have 2 over 3. S to the 7th minus the 3rd gives me s to the 4th. T to the 11th minus the 8th is t to the 3rd, and that is my final answer. Okay. On a problem like B, they're trying to trick you a little bit here, because this is not a fraction right now, right? But I can make it a fraction by putting it all over 1. Don't forget that, okay? I can always make something a fraction by putting it over 1. So I'm going to rewrite my problem as 20r squared minus 10r over 35. Division changes to multiplication. Take the reciprocal, so I have 1 over 4r minus 2. Now again, I'm multiplying this quantity times this quantity, just like before. So I have 20r squared minus 10r times 1, okay, which is going to be itself. And then I have 35 times 4r minus 2. So if I distribute my 1, distribute my 35, okay, this top is going to stay the same, 20r squared minus 10r over on the bottom 35 excuse me, 35 times 4r, 35 times 2 is 70, so times 4 would be 140. R minus 35 times 2 is 70. Okay, so now that I'm here, I'm going to simplify this as far as I can. So on top, oops, let's move this over. On top, I can factor out 10 and r from both, so I'm going to do that. 10r leaves me with, whenever I take 10 out of 20, I get 2. R squared, take out an r, gives me r, minus 10r divided by 10r is 1. Over, on the bottom, I can take 70 out of both. If I do that, I'm left with 140 divided by 70 is 2. R minus 70 divided by 70 is 1. Again, these quantities will cancel. I can also cancel a 0, which means that my final answer is 1r, or just r, over 7. Final answer. I would like for you to try C on your own paper at this time. Please pause the video so they have time to work. on C, we're going to do the same thing. We have to deal with the fact that it's division, so we're going to start by rewriting it so that it's no longer division. I have x squared minus 5x minus 14 over x squared. Division changes to multiplication, and then I'm going to take the reciprocal here, so I have x over x plus 2. Okay. Multiplying these two quantities times each other, so I can rewrite this as x squared minus 5x minus 14 times x over x squared times x plus 2. Okay. So now that I'm here looking at this, I have a trinomial here, right? And whenever we see trinomial, the first thing that we're supposed to think is to factor. If I distribute this x in here, I'm going to end up factoring it right back out. So I don't want to do that. So instead, I'm going to factor this as it is. So 14, I need something that multiplies to get 14 and adds to get negative 5. Okay, so things that multiply to get 14 are 1 and 14 and 2 and 7. So from those I can get a 5 out of 2 and 7. So I'm going to split up that trinomial, split up my x squared into x times x. I'm multiplying to get a negative, so I know I have to have a positive and a negative. Because I want a negative 5, I know the larger number here has to be negative, so 7 has to be negative, 2 has to be positive, and that's all being multiplied by x all over x squared, and then times the quantity of x plus 2. So now I see this quantity will cancel with this quantity, so I could write that as x times x minus 7 over x squared. But I still have these that I can reduce. This is x to the first. I'm going to take it and move it down, subtract it from that 2, so I'm left with x minus 7 over x to the 2 minus 1 is just x. Final answer. Example 5. A store makes a profit of x squared over the quantity of 10x plus $20 for each item sold. If the store sells x squared plus 5x plus 6 items, what is the total profit in terms of x? Okay, if I told you you made 50 cents for every item sold and you sold 10 items, I hope that you would say that we would figure out the profit by multiplying those two. Okay, because that's what we're going to do here. We need to take how much is being made for each item times the number of items. So I have x squared over 10x plus 20. And then I'm multiplying that by the quantity of x squared plus 5x plus 6. Okay? Now when I do this, I'm going to set it up as two fractions. And then I can just multiply across. I'm going to rewrite it as x squared times the quantity of x squared plus 5x plus 6 all over. When I multiply anything times 1, I get that anything. So I just get 10x plus 20. Okay. On top, I have a trinomial here that I can factor, so I need something that will multiply to get me 6, add to get me 5. So I have x squared, I'm going to split up those parentheses. Things that multiply to get me 6 are 6 and 1 and 2 and 3. Because these are both positive, I know I have to have positives in here. Okay. So the only way I can have both positive and get 5 is 2 and 3. Over, on the denominator, I can factor a 10 out of both. So if I take a 10 out, I'm left with x in the first part, and 20 divided by 10 is 2 for the second part. So this will cancel with this, and I have x squared times the quantity of x plus 3 all over 10. Now let me check and see if that's how they leave your final answer. And they do. So that is our answer in terms of x. When it says in terms of x, that means that x is going to be part of our answer. Okay, so that is all that I have for you today. For your homework, I want you to do A through H, and we are going to do 12 through 22 today. A through H and 12 through 22. And this is from less than 88, A through H, and 12 through 22. That's all I have for you. I hope that you have a good rest of the day.